Hello friends, welcome to my YouTube channel. In this video, I am going to explain how to use Tikz to have special effects in matrices coding in LaTeX. Let us take up the Technique Center editor. As before, we use the document class article and we use the package AMS Math. Since we are going to use Tikz, we load Tikz.style along with the Tikz libraries matrix, positioning, fit and Tikz mark. Now, for convenience, I define a new command /x which is end document. Let us first consider the very simple case of a matrix with the options draw, thick, column sub and row sub. In the first row, first column, we have only node A, and then in the first row, second column, we draw a circle within which we place a node B. Similarly, in the second row, on compilation, you get this as the output. Suppose you want, you may remove this coding and use this coding. Let us say node a circle C. Now you will not have the enclosing circle. If you are interested, you can say draw and then you will have the circle. This way also you can code it. Let us say you are not interested in the bounding square box, then you remove here the option draw. Then you will have only the 2 by 2 matrix. Now, let us take the next case. I define a style for every matrix, which is a matrix of math nodes with column separation, row separation, left delimiter, right delimiter, etc. And then I use the name for the defined matrix my mat. This is a 3 by 3 matrix. And I use here a node for connecting the 1 element of the defined matrix to 1 element of the matrix. Similarly, this will be a node enclosing the row. Similarly, I define another node connecting 1 element and 3 element. This will be a column node. And for a special purpose, I define a command like this, draw this, and here let me compile and show you the result. You find here in the first case we defined the node which is having a color red like this, starting from the element 1 up to the element 1 Then here we have the node connecting 1 to 3 and this is a column node and this is blue in color. And then you may be tempted to draw this diagonal node saying that start from 1 element, go up to 3 element like this. Suppose you say start from 1 element, go up to 3 element, then you will be surprised at the result. You have the node enclosing 1 element and 3 element, but this is not diagonal, it encloses the whole matrix. Therefore, this cannot be used. However, we can use another command like this, draw, this is a x coordinate, west of the element 1 start here somewhere here, and then the y coordinate is north of 1 element, somewhere here. This pipe followed by hyphen tells us that this is a x coordinate, this is a y coordinate. From this point, go up to this point, east of 3 element and south of 3 element. East of 3 element is somewhere here, south of 3 element is somewhere here, and therefore on compilation you will get a diagonal node like this. Suppose you want to beautify this, what you can do is you can add x, y shifts as in this case, then you will find the same node will appear to be beautiful. Now, let us take another case. Here, we define a style Kalidas with the minimum height, matrix of nodes, row separation, column separation, etc. And I name the matrix as first. The style used is Kalidas. Here we have a 2 by 2 matrix. And then we have another matrix, I name it as second. This matrix is placed on the right of the first matrix. The style used is again Kalidas. In the case of Kalidas, we define the style of column 1, column 2, column 3, etc. And therefore, on compilation, you will find the elements like this, the matrices like this. This is column 1, and here we have not used node. Similarly, if you remove here the node, for the second column also, the bounding boxes will not appear. Now, let me have it as before. Another important point is, suppose you say row separation is commented out, then what will happen is, you will have here a very thick horizontal line. It indicates for the first cell, you have here a bottom line. For the second cell, you have here a top line. They are placed adjacent to each other. Therefore, the horizontal line here appears to be very thick. That is why we say, let those lines overlap. We give the command row sep equal to minus pgf line width. Similarly for column sep. Then you will find the line to be a very simple line as before. Now, if you want, you can define one more matrix. You can place it on the right hand side of the second matrix and so on. That you can do it by yourself. Let us take another case. I define a Tikz set, my style. And as before, we use nodes in empty cells, matrix of nodes, row sep, column sep, etc. And here we have 1, 2, 3, 4 column matrix. And you will find the matrix is like this. If you do not want to have the horizontal and vertical lines, you can remove them. You can say, remove this, draw, and then you will have only the nodes A, B, C, D, etc. without the horizontal and vertical lines. Now, on compilation, you will find a sort of chessboard. Now, suppose you want to color it. You can define another style C and use that style in the rows and columns. Then you will find the same matrix similar to a chessboard. Remember, if you fail to give the square brackets on the left and right of C, then the bounding lines will disappear. That is why we give the square brackets on either side of C. You will have here the bounding lines. Now, suppose you have two matrices. We want to connect first to the second matrix. Then we go for an elaborate coding like this. First we define a box matrix with the two arguments, and for this purpose we use Tikz mark library. I repeat, for this purpose we use Tikz mark library. With the Tikz mark, this is compulsory. These two, remember picture, comma, overlay, these two options are compulsory. Then we define the command draw, and here this is the name of the node that you are going to define. And then for this rectangle, this defines #2 defines the width of that node. Similarly, for box entry, again these two, remember picture and overlay, are compulsory. And then here we have an option 1 within square bracket, and here this is the compulsory argument 2, #2. This is the name of the node. Then we start Tikz picture, and then we define a color, and here the name of the node is top A, and here the name of the node is bottom A. From top A to bottom A, we draw a rectangle. Then again we draw a line from the node start A up to the node top A, and how the line should be bent, that is given here. Outwards is 90 degrees and inwards is 90 degrees as before. Then the second matrix can be a boxed matrix like this. We give the name start AAA, start JRA, start JBA. The width is 3 cm, 3 cm, 3 cm. And then we start typesetting the first matrix using AMS math package, begin B matrix, end B matrix. And here this entry is box entry. Box entry is already defined, and therefore you will have the node 8. And we say this is Tikz mark start A, and this is what we refer to here. Draw here start A 9. And then second matrix is given in terms of the array environment. Then we say Tikz mark is this, and this is an entry there, and then Tikz mark top A, etc. And on compilation we have, when you compile it for the first time, this is what you get. When you compile it once again, you will find this is the first matrix typeset using B matrix of AMS math package. This is the second matrix typeset using array environment. The colors are already defined. Then we, from this point up, from this node up to this node, we draw a connecting line. This line can be changed like this. Let us say outward is 120. Here it changes, and so on. This way you can connect two matrices. The last example I have taken from this website, and you will find a beautifully typeset matrix like this. If you require a matrix of this type, better refer to this particular website. I am specifically interested in the sentences that precede and follow this matrix. This matrix is typeset like this. First we define the nodes, and then we draw the lines using the nodes, etc. And then Suppose you say I remove this 1 centimeter option, then you will find here the columns are closer together. Therefore, I would like to have 1 centimeter here. Thank you very much for watching. We will continue in the next video.